And number 49, first they ask us to graph the polar curve using technology, and what a beautiful graph it is. Next, they ask us to find an interval for theta. For what values of theta will the graph be traced only once? We can use technology, so we can figure this out with trial and error. We can also make a pretty decent educated guess as to the path of this particle. I'm not sure where it starts right now, but if you just continue doing the circles, 1, 2, 3 trips back to the pole, 4 trips back to the pole, 5 trips back to the pole, 6 trips back to the pole. Then if we had to do this without technology, we could just collect a table and find out how long it takes if we start at the pole to do a single loop. And whatever that interval of t was, we could just increase it by a factor of 6 because there's 6 of these loops. But I'm just going to use technology. Well, no, actually, let's just do this algebraically. Focus, if you will, on the pole. How long will it take if we start at the pole and leave to get back to the pole that first time? We can figure that out because when we start at the pole, r is 0. And when we leave, we won't come back to the pole until r is 0 once again. So we can just find 2 consecutive values of theta that take us from an r equals 0 to the next r equals 0. And whatever that interval is, we can multiply that by 6. All right, so when is that radius equal to 0? When cosine of 3 theta over 4 is equal to 0. And when is that true? We're asking for a cosine ratio. We're wondering when is it equal to 0? Well, that's the x-coordinate. And the x-coordinate is equal to 0 here and here. So 2 consecutive values of theta, which give us a radius of 0, could be when the angle is pi over 2, or maybe 3 pi over 2. Those would be consecutive ones. So the angle is 3 pi over 4, 3 theta over 4. So 3 theta over 4 is equal to pi over 2, or 3 pi over 2, when 3 theta is equal to 2 pi, or 6 pi. So when theta is equal to 2/3 pi, or 2 pi. So what we just did, recall, was we figured out 2 consecutive values of an angle theta, which give us a radius of 0. So the radius is 0, then it's not 0, then it comes back to the 0. We've done one loop, and that will happen, as one example, between theta equals 2 pi over 3 and 2 pi. So that's 1 1/3 or 4/3 pi for a loop. So if it's 4/3 pi for one loop, then we need 6 loops, which gives us 24 pi over 3, or 8 pi. So we're going to need an interval of 8 pi radians to draw this entire beautiful picture one time. So I would say when theta between negative 4 pi and 4 pi. Once you get past 4 pi, you start repeating a part of the path that you've already started. And we can really take any boundaries as long as the distance between them was 8 pi. So for example, from 0 to 8 pi would work just as well.